Hi, how are you all? Myself, I am Nitish Kumar. Today we are going to discuss the lecture 2 of fluid mechanics. Okay, in the previous lecture we have just introduced what is the fluid and what we learned in the fluid mechanics. And another thing we have discussed is variation of pressure vertically with depth. Today we are going to discuss variation of pressure horizontally and variation of pressure in accelerated fluids. Okay, first topics are variation of pressure horizontally, variation of pressure horizontally. Second thing is variation of pressure in accelerated fluids in vertical. Okay, in vertical. Okay, let's start. First, variation of pressure horizontally. Okay, for example, first we have to take a beaker which contains a fluid, okay, we have to find what will happen to the pressure if we move, what changes occur in the pressure if we move like this. Okay, if we increase, or if you move an object or anything like this, what will happen? For that we have to imagine a cylinder, hollow cylinder. Okay, we are just imagining a hollow cylinder in it. Okay, I am just drawing that hollow cylinder outside for the sake of good vision. Okay, this is a hollow cylinder. Okay, here in it fluid is flowing. Okay, let us assume here pressure is P1. Here pressure is P1 at this point, and the force is, I told that pressure is force upon area. Pressure is equal to perpendicular force upon area, so that force is equals to P into A. Here just P1, so the force applied here, force applied on this direction is P1A. Here let us assume the pressure is P2, the force applied is P2A. Okay, the force applied is P2A. Here these two forces are equal. Okay, P1A is equal to P2A because P1, P2 are different. And area. Okay, and this area is same in entire surface. That area is same. So P1A is equal to P2A. This A and this A get cancelled, so that P1 is equal to P2. From this we can get a conclusion that at any point while we move like this in a fluid, at any point in a static fluid, means the fluid we are considering it here, we are considering the fluid is at rest. When we move like this when we move horizontally like this in a rest fluid, then the pressure at any point, at any point, at this point or at this point, or at any point, the pressure is P is same at any point. Okay, at any point P is same. And the other thing is, another thing is here shape of the vessel. Another note point, this is very important point. Here shape of vessel doesn't affect pressure. Here we have to not consider the shape of vessel, whatever it may be. The shape is anything, it may be the shape is anything like this, or this, or this, whatever it may be. Shape is anything, but we didn't consider any shape, but we'll consider height. we will just consider height. Okay, we will just consider height. Okay, next, variation of pressure. Variation of pressure in accelerated fluid. In accelerated fluid. Okay, here also there will be two cases. First one is vertical acceleration. Second one is horizontal acceleration. Today we are going to discuss about vertical acceleration. Okay, it is case 1. Vertical acceleration in the sense it may be upwards or it may be downwards. Okay, it may be upwards or it may be downwards. Also same thing, let us assume we have to take a container and a fluid in it. Okay, and let us assume the acceleration of the fluid is upwards. The acceleration is upwards and the height is h. Fluid is being accelerated upwards. Okay, and here area is A, and the density of the water is rho. The pressure is P. Okay, from the frame of the vessel, liquid is at rest. Means if any object is there inside the fluid, then they feel that the fluid is in rest. But any object is outside the fluid, then we will feel that liquid is accelerating. But we are just considering inside the water, any object is there, then that also is moving with same acceleration, so that it feels that the liquid is at rest. Okay, but I am again drawing that. Okay, the atmospheric pressure is P naught into A, and the height is h. And pressure will be upwards and gravity will be downwards. mg, acceleration will be upwards. Mass into acceleration. Okay, mass into acceleration. That is all or in same direction except PA. P naught A plus mg plus ma is equal to PA. Here a small mistake. And here P naught A plus m into g plus a is equal to P into A. We know that m is equal to rho into A into height. Okay, rho into A into height. So that P naught A plus rho AH into G plus A is equals to P into A. Here A get cancelled, so that P is equals to P naught plus rho into GH plus AH. Here just take the H common, so that P is equals to P naught plus rho into G plus A into H. Here this is the formula for the accelerated fluid when it is accelerating upwards. upwards. And now when it is accelerating downwards, what will happen? We will see now. What will happen? We will see now. Okay. There is a fluid inside it, and acceleration is downwards, height is h, pressure is downwards. Okay, and here the pressure is atmospheric pressure is P naught. So that here also same situation, but somewhat difference is there. So that P naught A plus mg is equal to Pa plus m into A. Okay, P naught A plus mg minus ma is equal to P into A. Here also same thing, m is equals to rho into A into height. P naught A plus rho into A into height into g minus A is equal to P into A. A get cancelled. So that here P is equal to P naught plus rho into g minus A into h. This is a formula for the fluid which is accelerating. Now notes, that's it for today's session. And if you have any doubts, please ask me in the comment box. And if you like this video, please hit the like button and subscribe to our channel MPC Concepts.